Hello, and welcome back to, I guess, Advent of Code 2025 day 7. A series where I'm playing through all of the days of Advent of Code until I stop enjoying playing them. Still enjoying it. Still here. Will this be the one that finally kills me? Maybe. Maybe. Let's jump in. Day 7, Laboratories. You thank the cephalopods for the help and exit the trash compactor, finding yourself in the familiar halls of a North Pole research wing. Based on a large sign that says Teleporter Hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large yellow teleporter pad. Suddenly you find yourself in an unfamiliar room. The room has no doors, and the only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Oh, you hate to see that. Since this is a teleporter lab, there are lots of spare parts, manuals, and diagnostic equipment lying around. After connecting one of the diagnostic tools, it helpfully displays the error code "Oh no," which apparently means that there's an issue with one of the tachyon manifolds. You quickly locate a diagram of the tachyon manifold, your puzzle input. A tachyon beam enters the manifold at the location marked S. Tachyon beams always move downward. Tachyon beams pass freely through an empty space. However, a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam continues from the immediate left and from the immediate right of the splitter. An example, the incoming tachyon beam extends downward from S until it reaches the first splitter. At that point, the original beam stops and two new beams are emitted from the splitter. Those beams continue downward until they reach more splitters. At this point, the two splitters create a total of only 3 tachyon beams since they are both dumping tachyons into the same place between them. This process continues until all of the tachyon beams reach a splitter or exit the manifold. To repair the teleporter, you first need to understand the beam splitting properties of the tachyon manifold. In this example, tachyon beam is split a total of 21 times. Analyze your manifold diagram. How many times will the beam be split? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Some of these combine. Yeah, okay. Okay. How big is my input here? I mean, I can simulate it. I can simulate it. Alright, I'm going to assume I can get away with simulating this. This might be way too slow, we'll see. Well, I was counting the number of splitters, but that's not actually right. You're supposed to count the number of beams that come out of both sides, but a lot of them were combining, so that's the reason why the count was not lining up. I realized after I got done counting it that that wasn't actually what I was looking for. For line in F. The very last thing I'm going to do in here is read line. I don't think that'll mess me up, but it might. We'll see. For line in F. F.read line. Beams dot append index of S. So I think basically what I want to do is I can simulate this pretty easily by just checking to see whether or not the index of a beam, so for x in beams, if line at x is equal to what if there's already one coming down? Does that count as a split? I want to use this as my puzzle input for now, and I'll go back to the original one afterwards. If line equals line x line x equals well, if line is just dot, then beams append x. I can do a set for this, I think. Do I want to do a set for, I think I want to do a set for this. There's a few reasons why that'll benefit me. Sets are more efficient just for lookup. I'm not. If then new beams. I don't fully understand what happens in the case where a splitter dumps a line into a spot where there was already a line. That's what I need to figure out. Let's do this. For x in beams, line x is equal to dot new beams add x. Basically, I'll be able to swap these if I have my understanding backwards, so it'll be easy to fix. Line x, then I just need to check to the left and the right for nx in x minus 1 and x plus 1. If new beams, if nx not in new beams, then new beams add nx, and splits add 1. And then the very last thing is beams equals new beams. So I start with 7. For x in beams, if line x equals a period, Wait. That's because that's not my input, dummy. $29. So let's swap these two then. That gives me 33. Okay, so I'm a little off here. 0, 2, 4, 6, 8, 10, 11, 12, 14. So I have the beams are correct. It's what constitutes a split I don't understand then. Okay. Okay. Oh, maybe I was misunderstanding how this works. It doesn't matter the order, I guess. It's just the number of times splits occur. Okay. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you are surprised to discover that it isn't a classical tachyon manifold, it's a quantum tachyon manifold. With a quantum tachyon manifold, only a single tachyon particle is sent through the manifold. A tachyon particle takes both the left and the right path of each splitter encountered. Since this is impossible, the manual recommends the mini-world's interpretation of quantum tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left, and the other timeline, the particle went right. To fix the manifold, what you really need to know is the number of timelines active after a single particle completes all of its possible journeys through the manifold. In the above example, there are many timelines. For instance, there's the timeline where the particle always went left, or the timeline where the particle alternated going left and right at each splitter, or there's the timeline where the particle ends up at the same point as the alternating timeline, but takes a totally different path to get there. In this example, in total, the particle ends up on 40 different timelines. Apply the mini-world's interpretation of quantum tachyon splitting to your manifold diagram. In total, how many different timelines would a single tachyon particle end up on? Okay. That's fine. That's fine. So there's a recursive solution to this, but I think it might be too slow. So I'm just trying to think of how I would solve this one in a slightly better way. Give me a moment to think about this. So the idea here is, what I want to do is I want to look at all of the paths that a particle takes below it, and for a given for a given splitter, it's all the possibilities it took on the left plus all the possibilities it took on the right for a given location. You might be able to build this up from the bottom. You might be able to build this up from the bottom. I don't think I want to keep any of this for part 2. That's not entirely true. I want to keep this line. Thank you. Okay, so for line in F, if caret is in the line, then I want to split dot append x for x in I for ix in enumerate line if x is caret. So it's going to give me the locations per line. And then I want to reverse the whole thing. So split, reverse. Okay, let's see where we're at there. Yes, so I want to go from the bottom up, I think. I want these to be sets, I think. Yes. Okay. And so now what I'm going to do is, from the bottom, each one of those represents 2 different paths. So the first thing I need to do is I need to make a path count dictionary. Oh god. I'm just gonna have to... Jesus, type right. Okay, that's fine. And then for... in split... Basically what I want to do is, for the next line up, I want to say, for k in p count, if for x in
Never give up.
k minus 1, k plus 1, if s list, if x in s list, p count 2 equals p count 2 at x. Hey Lizzie, thanks for the Prime Gaming sub. P count 2 dot get x 0 is my default plus v. Too low. Okay. Every splitter at the bottom level has a left and a right, so there's two paths here. I go up the tree, and for every splitter I see to the left or to the right of this point, I add it to the thing on the left and the thing on the right. Add this to my code. You got it, boss. Hi, Bubs. I think it's too low because I'm not handling the situation in which a path that diverts off the left or to the right doesn't go anywhere. I don't think this works. Yeah, I don't think this works. Building from the bottom up does not work. Yeah, building from the bottom does not work. None of this code is correct. Zero percent of this code is correct. I just thought of a case where it does not work the way I think it does. That's fine. Okay, if you make it to the bottom, there's one solution that gets there. Otherwise, return solve I plus 1. So going on to the next one. If this is not where a splitter is, then we keep that same location. Otherwise, this is the location of a splitter, and I'm going to return solve I plus 1 of x minus 1 plus solve I plus 1 x plus 1. And I definitely need to memorize this. Think this works? No shot. That seems way too large. Oh, okay, that's the right answer. Never mind. Okay, cool. Yeah, so this is a fairly standard memoization approach. The problem with going from the bottom to the top is that sometimes a beam is created because it was split from a left or a right side, and sometimes a beam exists because it's coming down unimpeded from an above row. And so it's hard when you're going from the bottom up to determine whether or not a beam has arrived at this location because of a splitter or not. I'm sure that there was a way for me to fix that problem, but it was not a problem I wanted to fix enough. Guess you can try to scan the string down to follow a beam's path. I mean, possibly. I think that that's a messy approach. Not impossible, just... I realized very early on that I had hit a problem with the solution that I didn't care to fix. Hi, Bubs Up. Alright. Thank you for watching today's Advent of Code. I'm going to move on to playing some games. See you, YouTube.